Hi, this is Dr. Steve Piloff. I want to talk to you guys about a special kind of problem. It's a two-part problem. In part one, there's savings with an annuity or an annuity due, where you save some money and at some point in time you have money accumulated. And then in part two, you withdraw those funds as an annuity, annuity due, or perpetuity. So either you're withdrawing for forever with a perpetuity or for a fixed amount of time. So, you might save for retirement and then withdraw during retirement. One type of this kind of problem is such that all the information that you need in part one is given. So, you know if it's an annuity or annuity due, meaning that you know if you start saving in one period or right away, you know how much you save each period, you know how many periods you'll be saving for, you know what the interest rate is or the return that you expect. So you can figure out how much money you'll have at a particular point in time. Then part two is based on the fact that, okay, we've got this amount of money and now it's time to withdraw, and how much can we draw per period? Or suppose it's a growing perpetuity where we're collecting to pay for a scholarship that's going to increase by a certain amount. What is that growth rate if we're given what the first payment is? We already know the rate. Those kinds of things. So it's a kind of question that involves two parts. A couple of notes for this class for this type of problem. Timelines. Timelines are very, very useful. It helps identify when things are happening, how many things are happening, those kinds of things. When the savings in part one is annuity or annuity due, which is what happens in these kinds of problems, we'll be asking for the future value as of time n. That's the number of payments, the number of savings contributions. So it doesn't matter if they start right away or they start in one period. If there's 10 contributions to savings, then we'll want to know how much we have at time 10. And you can think of that time n as, in a sense, the pivot point, because you're going to save to that point in time, and then when you do time part two, that is going to be the new time zero. So here I drew, suppose that's an annuity due with 1, 2, 3, 4 payments. So even though they're going to be at time 0, 1, 2, and 3, time 4 would become our new time 0 because we'll know how much we have at time 4. So the number of payments from part 1 serves as a pivot point on our timeline. It's when we have our future value, and it is in part 2 our new time 0. So let's take a look at an example. How much can Tammy expect to withdraw each year in retirement? So she's going to save $30,000 per year for 3 years. So we know she's going to make 3 contributions, 30, 30, and 30. The first one is expected in 1 year. Then in 3 years she plans to retire. In retirement, so when she retires, she plans to receive equal annual payments for 5 years. So once, twice, 3 times, 4 times, 5 times, she's going to get a check in the mail, and that check all 5 times is going to have the same amount on it. First retirement payment will receive 1 year after she retires. Well, she retires in 3 years, and so 1 year after is going to be in 4 years, and the expected return is 15%. So it's a lot going on there. Timeline can help us understand it. So let's draw a timeline. So this is kind of the first part. She's going to save $30,000 per year for 3 years, and she's going to start in 1 year. So 1 year, 2 years, 3 years, 30,000, and we'll figure out how much she has in 3 years, which is actually when she retires, at 15%. So 30 times 1.15 squared plus 30 times 1.15 plus 30 is how much she'll have when she retires in 3 years. We can figure that out as the future value of an annuity. Then, once she retires, she plans to receive equal payments for 5 years with 1 year after retire. So again, you can set the retime. Since there's 3 payments, that's our new time 0, our pivot point. 1, 2, 3, 4, 5. And we want to know what are those cash flows such that their present value is equal to the amount saved. So the first thing we got to figure out is how much she's going to retire with, and then now we know, okay, we have a present value of an annuity that's equal to the amount that she saved. What's the payment associated with that? And again, the new time zero is 3 since there's 3 payments. So again, 30 times 1.15 squared plus 30 times 1.15 plus 30. That's 3 contributions into the account of 30, starting in one period. She didn't have anything saved up, and so in 3 years, she'll have $104,175. That's how much she expects to have at this point in time. So now, if she expects to have 104,175, then that's how much she, you know, her annuity, the present value of her annuity. So we want to know what C, such as C over 1.15 plus C over 1.15 squared plus C over 1.15 to the third plus C over 1.15 to the fourth plus C over 1.15 to the fifth is equal to 104,175. And so that's finding the payment associated with a 5-period annuity. So again, there's 5 payments. They start in one period. And again, remember, our new time zero is 3 years from now, and her first payment in this case is 1 year later. That's why we're in end mode. 104,175, and she can expect to withdraw $31,077 each year in retirement.